So what is this strange beast you've come across reading about Couchbase, called an upsert? Well, as we'll see here, it's simply the logical consequence of our speed-focused architecture. So why is Couchbase Server so fast? As you learn in the Essentials course, it's because operations are served and acknowledged primarily from cache. Disk writes, which do happen after data enters cache, are append only, whether it's a new insertion or a replacement of an existing document. So if you append a new document, a document with a new ID, that is an insert and it creates that document in Couchbase. On the other hand, if you happen to append a document whose document ID already exists, then what you're doing is replacing that document, which has the same behaviors you would expect from an update operation. Let's visualize. So imagine you have 3 documents on disk, doc IDs 1, 2, and 3, and then somebody adds another document, doc ID 1. That functionally replaces the value of the prior doc ID 1, and so the value of doc ID 1 on the next read will be 1, 2, 3. A few new documents are added, and then another document comes in for a doc ID that already exists, 2. That replaces the prior doc ID 2, effectively updating its value. Similar with the third instance of doc ID 1 that gets added in. Now the value of doc ID 1 is 789. So then, what is an upsert? It's simply the consequence of the architecture we just looked at being pushed through to the SDK. So the bucket class exposes a method called upsert, and it's very much like the replace that we just looked at in the last lesson. It takes a document as a parameter, likely a JSON document, and you can set persistence, replication, and timeout parameters. So what this method does is it inserts or replaces a document. Well, think about it for a moment. All it really needs to do to achieve that is to stop testing for the existence of the document. So you can set replication constraints. They'll always check best practices before assuming you need them. You can set persistence constraints. By default, acknowledgement happens as soon as a value is written to cache, but you can set it to be more stringent and it has to be written to local disk or persisted throughout the cluster. Various settings you could choose here. You can also set a granular timeout for this particular method call, and it's going to return a document with an updated check and set value. In code, it might look like this. So you have some local data object, some entity, which gets translated into a JSON document, and then that document is simply passed to the upsert method. Of course, you could set other parameters here. I'm sure you can imagine that. And then you get back the updated document with the updated check and set value. You then pass that document into the rest of your application with whatever is appropriate. You could also use the query method and use nickel to perform an upsert operation. And of course, it's an evolving question. When is it appropriate to use the power of nickel for something that could equally be done by a simple method call through the upsert operation, as you see here? So then, how are replace and upsert different? Well, if you're thinking about this a bit, the question really boils down to, does Couchbase check for the existence of a document ID before appending? If it does check for the existence of the document, which may be logically significant for your application, and throws a document not found exception if it doesn't find it, well, then you're doing replace operations. On the other hand, if it's not checking for the existence, then what you're doing is upserting, which is really, really fast. Which one you use depends on the logical requirements of your application. You can insert and replace, or you can do it all with upserts. So when would an upsert throw an exception? The usual circumstances from what you've seen. If you have set a timeout value for this particular method call, or if there's a default, well, then it may throw a timeout exception. And the others are there as well. Back pressure, request too big, request canceled, temporary failure, Couchbase out of memory, or just a general Couchbase exception. All of those may be there for you to handle as appropriate. So in the lab here, we're going to do an upsert to insert or replace our incoming documents. Now, in and of itself, it's not that big of a method call. It's thinking through the implications of this for the purposes of the rest of your application where it gets more interesting. Now here in Couchbase repository, you'll be going to the upsert method, and in the upsert method of the repository, you're going to call the upsert method of the bucket. Now in and of itself, that's a very small change. Where things get more interesting is in what you then need to do over in base controller, because base controller is handling post methods by calling the create method of the repository, which, as you recall, is what uses the insert method of the bucket. And then the put method is being handled by calling the update method of your repository, which is currently configured is replacing the document. So if we're changing over to use upserts here in our repository, think through, what are you going to do to a put and a post in a REST API relative to an upsert operation? So that's the chewy bit of this lab. Go ahead and jump in and get to work. When you're done with that, or as done as you want to be, hope you come back for the next lesson.